So here's some problems to try, and go ahead and go through these slowly and try to learn from them. Even if they're hard, try to learn from them. A reminder of the things that you need to consider in determining the outcome of the reaction. Remember to first classify that carbon. Primary and secondary do SN2 or E2. Secondary and tertiary can do SN2 or SN1. Look then at the contributing factors, the nucleophile, the leaving group, and the solvent. If you have a strong base in there with a secondary or a tertiary compound, you're going to have E2 occurring. Primary is not going to give you E2 unless you have TBOC in there. And then E1 occurs usually when there's heat. Okay, classify this major reaction. Well, I see that this is a primary halide, and we've got a good nucleophile. We've got a polar aprotic solvent. This is going to be an SN2 reaction. The cyanide's going to come in and displace the iodide, and you're going to get the cyano compound. We're not going to worry about naming that right now. Okay, what about with this alcohol, THF and methyl iodide? Now this reaction might have confused you because you're looking at the substrate usually being over here on the left and the nucleophile being over the arrow. Here, the substrate is this compound. You see, here's the leaving group. That is not a good leaving group. So the leaving group is on the iodine. What's going to be the nucleophile? The nucleophile is going to be this oxygen coming into the methyl group. This is a primary carbon. It's a methyl iodide. They're very fast in SN2 reactions. So the non-bonding pairs are going to come in here and displace this iodine, and this will be an SN2 reaction. The THF is a polar aprotic solvent, and so what we have here, everything points to SN2. Methyl iodide, THF, and a reasonable nucleophile. Classify the major reaction and write the product for these two reactions. Well, for this first reaction, the first thing that you notice is that we have a tertiary halide. We can eliminate SN2 if that's just not going to occur. Then I look over here and I see I've got a basic nucleophile. If I have a basic nucleophile and it's not primary, what's going to happen? E2. So that's an E2 reaction. Over here, I have a secondary carbon, and the secondary carbon has a good non-basic nucleophile here. This is non-basic, and it's got a good polar aprotic solvent. SN2 is going to happen here. The product here will be that this methoxide removes a proton from this, and it's going to make the alkene, the most highly substituted alkene. Over here, the nucleophile is going to come in and do inversion on this compound. So what do we get? We get the sulfide here, and we have inversion on that carbon. Okay, so classify these major reactions and write the product that forms. Okay, for the first reaction, I see that it's a secondary compound with a good leaving group. But I look over here and I see a bulky base. That bulky base cannot do SN2. Even though the conditions are good for SN2, the bulky base will not allow it. So we're going to have an E2 mechanism here. If I look down here, it's almost the same compound, but it's tertiary. If I look, there's heat with this compound. Heat's not going to allow SN1 to occur. Heat encourages E1 to occur. So what happens here is E1. So now this is an E2 reaction. So to figure out the compound, I have to have the anti-periplanar arrangement. So I rotate this around, and that's going to put the methyl back and the hydrogen forward, and that gives this compound. If I look at this compound, it doesn't matter which way it goes. You're going to get two compounds because you're going to have, after the tosyl group leaves and puts a positive charge here, rotation can occur, and so you're going to have flip-flopping of the methyl and the ethyl group. Classify the major reactions here and write the products. Well, first thing I do is I notice it's tertiary, and I have hydrochloric acid, and it's polar protic solvent. This is going to encourage SN1. It's acidic, no base, no heat. So that's going to be an SN1 reaction. If I look at this compound, it's secondary, but I've got a great nucleophile and a polar aprotic solvent. This is going to be SN2. The SN1 reaction, I protonate the alcohol, it leaves, and then the chlorine comes in. But this is a chiral compound right here. So what's going to happen is you're going to make the two compounds, both of these two compounds. In fact, this is a chiral carbon 2. So what do we see? We see two diastereomers made. If I look at the second reaction, we're going to get an SN2. The nucleophile is going to come in from behind and displace this. What product will form? You're going to have only one product form, and inversion is going to occur on this carbon.